Hey kids, welcome to section 6.7, natural logarithms. Today we're going to learn how to evaluate expressions involving the natural base and natural logarithm, and we're going to learn how to solve exponential equations and inequalities using natural logarithms. So first thing we need to talk about is what is a natural logarithm. So just like pi and root 2, the number e is an irrational number. That means it never repeats, never ends, and it keeps going on and on for forever and ever. The value of e is approximately 2.71828, and it's referred to as the natural base e. So anytime you see an e in math class that's not a variable, that is a base, we're talking roughly the number 2.71. An exponential function with a base e is called a natural base exponential function. So we're going to be looking at things like these, f of x equals e to the x, f of x equals e to the negative x. And based on whether that x value is positive or negative, we'll be looking at growth or decay. Now, just like exponential functions have an inverse in logarithms, natural base exponential functions have an inverse called the natural logarithm. So e to the x's go with ln x's, and anything else that has a different base can go with logarithms. So we still have this line y equals x that's going through the middle of the coordinate plane, and it allows us to have an inverse so that we can switch the x's and y's and graph the natural logarithm. So we've got exponential growth in the blue, and we have exponential decay in the blue on the right, and then their inverses are in red. So you can write an equivalent base e exponential equation for a natural logarithmic equation by using the fact that ln x equals log base e of x. So anytime you have log base e of x, that's your indication that you're working with a natural logarithm. So if I have ln 4 equals x, there's a little e down here. And so I can change it to log base e of 4 equals x, and therefore e to the x equals 4. You can also write an equivalent natural logarithm equation for a natural base e exponential equation. So if you have e to the x equals 12, I can rewrite it as ln 12 equals x, just like we do with exponential and logarithmic. There's also some properties of logarithms and natural logarithms that you can use. If you have e to the ln x, that just equals x. And if you have ln e to the x, that just equals x. Those are two laws. Okay, so let's practice writing exponential or logarithmic back and forth. Remember, if you have an e as the base, then you're writing a natural logarithm equation. So if I look at this first one, e to the x equals 9, I can take and change this to a logarithmic equation by saying ln e 9 equals x. So remember, you can do e to the x equals 9. Now, technically, I don't need that e there. So if I want to just write ln 9 equals x, that's perfectly fine. Right, letter B, e to the 7th equals x. So I can say ln base e of x equals 7. E to the 7 equals x. Again, I can clean that up and write ln x equals 7. If I look at letter C, ln x is approximately 2.1438. Remember, there's a little e right here that you can't always see because whenever it's an ln, there has to be an e. And so I can change this to exponential by saying e to the 2.1438 is equal to x. If I look at letter D, ln 18 equals x, there's a little e right here. And so I can say e to the x equals 18. So again, this page is just reminding you that ln and e go together. So if you want to undo ln x, you can use an e. If you want to undo e to the x, you can use an ln x. All right, let's see how we can solve some of these equations or inequalities round to 4 decimal places. So for letter A, I want to get the e to the 4x alone, so I'm going to add 12 to both sides. That gives me 3e to the 4x equals 27. I still have to get e to the 4x alone. I need to divide to get rid of the coefficient. E to the 4x equals 9. Now I can change this to logarithmic by taking and saying ln e 9 equals 4x. I can then kind of get rid of the e and just say ln 9 equals 4x. Divide both sides by 4 to get the x alone. 4 decimal places gives me 0.5493. Again, you can check and see if your answer is right or not by taking that decimal that we just got, plugging it in for x, doing the math on the left side, order of operations, and see if you get something close to 15. Okay, if we look at letter B, 17 equals 4e to the negative x plus 8. I need to get e to the negative 4x alone. So I need to get rid of the 8. So I subtract 17 minus 8 is 9 equals 4e to the negative x. I can divide both sides by 4, and I get 9/4 equals e to the negative x. I can change this to logarithmic by saying ln e of 9/4 equals negative x. The ln e, I don't need that either, so I can say ln 9/4 equals negative x. I can get the x alone by dividing by negative 1. And if I type ln 9/4 divided by negative 1 into my calculator, I get negative 0.8109. All right, if I introduce inequalities in C and D, the only thing I have to remember is that when I multiply or divide by a negative number, that switches the inequality. Other than that, I solve like normal. So I need to get the e to the x alone. So I'm going to minus 9 to both sides. Negative 3 e to the x equals, or not equals, is greater than negative 5. Divide both sides by negative 3. E to the x, I divided by a negative, so I need to flip the inequality, is less than. Negative divided by a negative is positive. Then I can change this to exponential or logarithmic and say ln e 5/3 is less than x. Hold on, that's weird. Okay, I'm going to show you a new thing that you can do that might help you a little bit more. Let's put 5/3 here. Yeah, so what you can do is in order to get rid of this e to the x, I showed you on a previous slide that if you have e to the x and you take the ln of it, that this equals x. That was a rule on a previous slide. So what I can do is I can take the natural log of both sides. I could have actually done this on all the other problems on this slide as well. I just thought I'd show you something different. So ln e to the x is just x. And then I have less than ln of 5/3. And ln of 5/3, if I type it into my calculator, is 0.5108. So there are different ways that you can solve these equations or inequalities. If you ever want to get rid of an e, you can take the ln of both sides. That'll get rid of the e. We'll try that tactic on letter D. So I need to get e to the negative x alone. Let's add 3 to both sides. 2e to the negative x is less than or equal to 11. Divide both sides by 2. E to the negative x is less than or equal to 11/2. I want to get that e gone, so I'm going to take the ln of both sides. Remember, whatever you do to one side, you have to do to the other side. Then I end up with negative x is less than or equal to ln of 11/2. Gotta get the x alone, so I need to divide by -1. I divided by a negative, so I need to flip the inequality to greater than or equal to, and I get negative 1.7047. All right, let's take a look at some more equations and inequalities. So just like the natural logarithm can be used to eliminate e to the x, the natural base exponential function can be used to eliminate ln x. All right, let's go the other way. All of these equations start with ln's, and we're going to solve them. So I need to, in letter A, 5 ln 6x equals 8. I need to get the ln 6x by itself. So I'm going to divide by 5. ln 6x equals 8/5. I don't know how to solve it the way it is, but I can introduce a little e. And so I can change it to exponential and say e to the 8/5 equals 6x. I can divide by 6. So if I type into my calculator e to the 8/5 and then divide by 6, I get 0.8255. Again, I can check and see if this is right or not by plugging x in here, doing 5 times the ln of 6x, and that should equal 8. All right, if I'm taking a look at letter B, I need to get to the x. Now we did learn some rules that says if we have an ln with a quantity and there is an exponent, I can bring that exponent down in front as a coefficient. So this becomes 3 ln 2x minus 3 is greater than 6. Now I don't have a cube that I have to worry about, and it just becomes a way easier problem. I can divide both sides by 3. That gives me ln of the quantity 2x minus 3 is greater than 2. I can remember there's a little e here. Change it to exponential. E to the second is greater than 2x minus 3. I can add 3 to both sides. So e squared plus 3 is greater than 2x. I can divide both sides by 2. And so if I type this into my calculator, I get 5.1945 is greater than x. But it's always a good idea to have the letter on the left side. And when I switch sides, I have to switch the way the inequality points as well. So there is my answer. X is less than 5.1945. All right, if we look at letter C, ln 5x plus ln x equals 7. Well, we learned that when you're adding two natural logs together, I can multiply the quantities. So this becomes ln times 5x, or ln of 5x times x equals 7. So this is ln of 5x squared equals 7. There's a little e here, so I can say e to the 7th equals 5x squared. I can divide both sides by 5. So that gives me x squared is equal to e to the 7th over 5. I can square root both sides to get rid of the square. When I square root, I get plus or minus. If I type e to the 7th over 5 square rooted into my calculator, I get 14.8097. I do have to remember that I cannot take the natural log of a negative number. So technically, my only answer is the positive option, 14.8097. All right, if we look at letter D, ln x is less than or equal to 3. Well, I don't have anything I need to combine, so I'm just going to go straight to, there's an e there. E to the 3rd is less than or equal to 8x. I can divide both sides by 8. That gives me 2.5107 is less than or equal to x. I should have the letter on the left, so x is greater than or equal to 2.5107. All right, now there are some word problems that can be done using natural logs and exponential. Interest that is compounded continuously can be found using e or the natural logarithm. So what compounded continuously interest is when you invest money, sometimes the interest is calculated once a year, sometimes the interest is calculated once a week. This interest is always compounded continuously over a certain number of years. And so the exponential one that we're going to mostly deal with is a equals PE to the RT. I call it PERT. And we're going to use this to calculate how much is in an account after so much time has passed. We can also use this if things are exponentially growing or exponentially decaying in real life. So let's look at this problem. If you deposited $800 in an account paying 4.5% interest compounded continuously, how much money would be in the account in 5 years? Okay, well, the equation is A equals PE to the RT power. Compounded continuously means this equation. The amount we deposit is our P value, that's our principal. The 4.5% is our R value, and we'll have to change this to a decimal, so 0.045. And the 5 is our T. So we're looking for how much money would be in the account. So we are looking for A equals our principal, which is 800, E, our R value is 0.045, and our T is 5. So all we have to do is type this into our calculator, 800e to the 0.045 times 5. This is a money problem, so we get $1,001.86. It should be a bigger number because we are earning interest. If you get a smaller number, you did something wrong. How long would it take for you to double your money? Well, you put 800 in, so doubling it would be 1,600. So I'm going to set my A value equal to 1,600 equals 800 e to the 0.045, and I'm going to put t because I don't know what the time is. That's the point of the problem. So to solve this equation, I can divide both sides by 800. That gives me 2 equals e to the 0.045t. I got to get to the exponent, so I need to get rid of the base. To do that, I can take the natural log of both sides. Now the left side doesn't get very exciting, it's just ln2, but the right side, the ln and the e cancel out, and you're left with 0.045t. Then I can solve for t by dividing by the coefficient 0.045. If I do this, I get t equals 15.4 years. There we go. All right, let's do one more word problem. Danger! A virus is spreading through a computer network according to the formula V of t equals 30e to the 0.1t, where V is the number of computers infected and t is the time in minutes. How many computers will be infected after 1.5 hours? Well, the first thing we have to notice is that t is in minutes. And so 1.5 hours is really 90 minutes. So I need to find what V is, because V is the number of computers, and I'm trying to find how many computers. So V equals 30 is my initial, e to the 0.1 times 90. So after an hour and a half, 243,093 computers will be infected. Basically, you're increasing the infections by 10% every minute. That's what that 0.1 means, is that you're increasing by 10%. So there's my number of computers. How long will it take the virus to infect 10,000 computers? Okay, well now my V is 10,000. So 10,000 equals 30e to 0.1t. Well, first thing I need to do is get rid of the 30. So let's divide both sides by 30. Now, when I divide by 30, I get a decimal. So I'm just going to leave it 1,000 over 3 equals e to the 0.1t. Then I need to get into the exponent. So I need to get rid of the e. I do that by taking the ln of both sides. Ln of 1,000 over 3 equals ln e to the 0.1t. On the right side, the ln and the e cancel, and I have 0.1t and ln 1,000 over 3 on the left. Divide both sides by 0.1, and I end up with t equals 58 minutes. So almost an hour later, we will have close to 10,000 computers infected. Finally, letter C, how many computers would need to be infected initially for the virus to spread to 1 million computers in 2 hours? So now I'm looking for what number should be in the 30 spot. I know what my number of computers is. That's 1,000,000. So 1 million equals, I don't know what 30 is. So I'm going to say A e to the 0.1, and it's after 2 hours, which is going to be 120 minutes. So I'm going to plug in 120 up here. So this becomes 1 million equals AE, and then 0.1 times 120 is 12. I can divide both sides by e to the 12th because even though it looks like it's a variable, it's not. And 1 million divided by e to the 12th, I get 6 computers. So if there were 6 computers initially infected, then 2 hours later, 1,000,000 computers will be infected. All right, kids, that is the end of 6.7. If you have any questions, please let me know. And as always, keep calm and keep trucking.